let's talk about some more thermodynamical process in this lecture. So we know, and let's begin by adiabatic process. So we know for an adiabatic process the heat pumped in is zero inside the system. So all the work done by the system actually comes, well, not like this, but W, all the work done, comes from the change in internal energy of the system. How to draw a PV diagram or pressure volume diagram for an adiabatic process. So let's do that. V is volume, P is pressure. To draw pressure volume diagram, let's first draw pressure volume diagram for an isothermal process. Let's change colors here. So here is the first isothermal process, and here's one more isothermal process. Okay, so this corresponds to some temperature, and this the other color corresponds to other temperature. And we know for an adiabatic process, as the work done is from the internal energy, the system loses energy, and because of that, there's a decrease in temperature. So your adiabatic process is going to look like this. And you can see the slope of adiabatic process is actually more than the isothermal process. So this is an adiabatic process. Let's talk about a few more processes. There are other like isobaric process. Isobaric means P equals a constant. P is a constant. For this case, we can say that P work done is pressure times V final minus V initial. That is one thing we can know for sure. There's something also called isochoric process actually, or volume process, or volumetric process people say. And so I think it's called isochoric process also. For an isochoric process, for an isobaric process, we know that the PV diagram is going to look like simply like this, straight line. So this is VI, VF. For an isochoric process, pressure volume diagram in fact has no meaning of its own, because all it has is a straight line like this. Volume does not change when the pressure can actually change, something like this. What can we tell for sure for isochoric process? For sure we can tell that work done is zero. So in some way we can extract some of the elements of this first law of thermodynamical equation, and then we can apply depending on the kind of problem we are dealing with. Alright.